one thing I am going to do before I put the glue on the side of this end slab and the inside edge of the border here is I'm going to just rough it with some 80 grit sandpaper here. A lot of times the planer kind of polishes the wood as it cuts, and this is just a plain jointed surface. It hasn't been sanded. So just to open up the pores of the wood, just going to give it a light scuff. You don't want to use a palm sander, right, because those can actually, leave divots and take a little bit too much off. So just a light hand sanding, that's all it needs. And then I'll do the inside edge here as well before I glue. That way the pores of the wood will be opened up and it'll absorb that glue a little bit better. I'm going to put in my device hardware after, which might be a mistake, who knows. But I'm new to this, same as you, so if I do screw it up, well, you'll learn and you'll do it a different way. So gluing this up, because these joints are really snug, I'm not going to put any glue on these tenons at all or in the mortises. I'm only going to put glue on the inside of the shoulder, the butt joint here, just to fill any voids and create a bit of a bond there, even though it won't be that strong, it's end grain. I'm just going to add glue there right as the joint's kind of getting tight. I'm going to put glue on these tenons, obviously, and these shoulders, so that'll glue this end piece in place. And once I put those wedges in there, man, that joint is it's bomb-proof. And then I'm going to apply, liberally glue along this joint surface and here where these two meet together, right? Like so. And same on the other side. So because the joinery in this is so skookum, the only point where you really need a lot of glue is on that laminated surface right here where the sides join to the table slabs. So there's going to be glue there, glue on these end tenons, and a little bit of glue on the inside, no glue on the tenons or in these mortises at all. That's how I'm doing it, because if I was to add glue to this, the friction it would add trying to assemble would probably prevent it from going together. So, be careful, because even those pieces there where they fit together fine dry, and I put the glue in, and it was a lot of muscle trying to put it back together with the glue, adding to that friction, sucking those joints together, especially those through tenons. The longer the joint, the longer the tenon, the more friction, so be careful. Do not put glue on these tenons. Just let the wedges do their thing. This joinery is designed to not need glue anyway, so we got plenty of strength here. You don't need to worry. Well, that was intense. As anybody knows who's done big glue-ups can make or break your project, and that one just about broke mine. Don't know if you could tell in the time lapse, but I was a little bit frantic. What happened was everything was going great. I had all the glue on here like this, and I was pounding the piece in. I had it almost tight. And so I was going to move over to the other end. I started gluing up this end, and all of a sudden I realized that the tenons, these tenons, both sets down there, I hadn't cut the saw curves for the wedges yet. I had glue all over everything. And so I quickly grabbed my saw, cut the curves in, were not the prettiest cuts, And obviously that threw sawdust into all my wet glue, which I then had to wipe off and then dry the tenons as quickly as I could, and then reapply the glue, all while this is still setting up. Thankfully, I was using a slow set glue, so that would be my pointer to you, is make sure you use a slow set glue. Don't use like a fast tack cabinet maker's glue. You want to use a slow setting PVA glue. I use Titebond 3, which is like a waterproof glue. You don't need to use that, but it's what I used. And thankfully, that probably saved my project, because if I was using a fast setting glue, all that glue would have started to set up, and trying to clamp these joints together probably would not have done it. So thankfully, I got it all together. Disaster was averted. You know, you can put a level across this way to check how flat your top is, right? And if you sand accordingly, you can make it all flat, but it might be going like this, right? And then if you put a level on this way, it's the same thing but reversed. You might have it flat this way, but it's got divots this way. So you hold your level on an angle like that, and that bridges the two axes, right? Horizontal, whatever, vertical. And then you use your level, and the aluminum leaves marks on the wood, right? Because aluminum just has that natural ability to scuff the wood. And so it'll show you where your high spots are. And you kind of do a bit of sanding, and then you run the level like this across your bench, and then you switch it like that. You run it across that way. And it'll show you where your high spots are, and you just sand accordingly. Now, if you've got a bench top that just did not turn out the way you wanted it to, and you got some real high and low spots, you don't need to worry. You got 3 inches of meat right here. So there's another method, a more extreme method, but a very precise and accurate method to leveling a top, and that's using a router sled. Now, I've made a video on my YouTube channel of how to make a 52-inch or really limitless width planer with a router. And what you do is you build a plywood box as long as you want, that's wide enough to fit your router base in, and you cut a slot right down the middle that'll fit whatever size bit you want. Now I've got this big 1-inch diameter fluted bit with the top mounted bearing. So I cut the slot in the middle of my box wide enough to fit this bit so that the bearing just, has enough room, but it's not rattling around in the slot, kind of like this, And then you put the sides on your box, you rip it all out of a nice sheet of plywood or MDF and screw it together so that the sides are keeping the box straight, right? It's from the weight of the router, that's what gives it rigidity. And then you put some ends on it, and you leave the top open, and the router just sits in there, right, and slides in that track. Once you have a nice box made and your router slides in it nicely, you just rip 2 more strips, nice straight. Try and use the factory edge of the sheet, and you put those on either side. You can just clamp them to it, and you raise it up past the top of your bench, maybe 1 inch, 2 inches, enough so that your blade can, adjust. And then you level those 2 straight edges perfectly with each other. And this is what I show you in the video how to do it. And when you get those perfectly level, you can use a laser level if you want to shoot them, or you can just put a level, check it on either end, make sure everything's straight, and it's got lots of clamps to to support the weight of the sled. And then once it's all clamped in there, you just put your box on your straight edges and you just go back and forth with your router. And now this takes a long time, and you'll cut into your straight edges, or you could put a spacer block if you want, if you don't want to wreck your straight edges. You put a little spacer block so that your router bit can get over the edge, and then has a stop, so that it doesn't hit your fences. And then those fences, you just run that thing across and just do whatever width your bit is, 3/4 inch, 1/2 inch, whatever. It might take 40 minutes with a 1/2 inch bit. It'd be half that with this. And you perfectly machine, basically, you're machining the top as flat as it can be. And once you're done that, you'll have, obviously, the bit marks, but those will sand out real easy with the orbital sander, or a real quick pass with the belt sander. So those are two methods to get your bench top just flawless. All right, so now we're laying out the sliding dead man's guide block. That's what I call it. I know it's a bit hard to see, but we're doing a tapered dovetail that's going to slide in from the side of the block. So here's the V notch, which is 1 inch deep from the edge, and then 45 degrees out, and then that starts 9/16 from the shoulder of our dovetail. So you mark, where your shoulder is, 1 inch from the edge. Then 9/16, that's the start of our V track, which is 1 inch deep, and then wherever the 45s line up, they line up. It's 2 inches wide finished. And then the shoulder, I've done 3/8 of an inch taper. So mark down 1 inch, go in 3/8, connect the dots. And then I've also, on the top, put a 3/8 taper. I marked 3/4 of an inch in from one side, because this dovetail is going to be blind. It won't come out the other side of the sliding dead man. It'll just look like a butt joint. So 3/4 in from the end of the 6-inch piece, you make a line across, and then I marked 3/8 of an inch in from each side, and then I connect the dots from there to the full width. So that's the taper of our dovetail. Now if we were to do the dovetail parallel all the way along, the friction that would be created trying to pound those surfaces together parallel would just be intense. Whereas these type of dovetails, which are prominent in a lot of different types of architecture and wood building in different parts of the world, but definitely in Japan, is the Japanese joinery is where I kind of learned the power of the tapered dovetail. So having it tapered like this, you can see the benefit is that as we start the joint is this wide, the opening, the mortise, and as this starts in here, it'll be loose, right? And so the piece will just slide in freehand, no problem, and then right as we get to the end of the joint, that's when you start to get contact and create that friction. So we're going to cut our joint just so that we get contact maybe about here, and then we just have to pound it that 1/2 inch to get really tight fit. And that way, if I ever want to take the dead man off, I can just knock this piece out, because I'm not going to glue it in place. It's just going to be a dry fit, pressure fit dovetail. So instead of making some fancy jig that's going to help me cut, these tapered dovetails on an angle, maybe you guys got one of those little tapered jigs, the hinge on it. I haven't made one of those yet, and I'm not going to fart around doing that right now. I'm just going to freehand cut these angled tapered cuts with my 6.5-inch circular saw. And right now I've just got the blade set up about 1/4 inch so that I can define my shoulders here. So I'll cut 1/4 inch cuts all the way through. I don't want to go the full 3/8 or else then there'll be a little square notch out of the side of your dovetail right where it meets, right? So I'm going to do that last 1/8 of an inch by hand so it doesn't notch the side of my dovetail profile. So yeah, just go up 1/4 inch, and then I'm going to set my fence 1 inch away to the outside of the blade. And then I'll just run my piece through, cut my shoulders nice, and then I'm going to finish the rest with my circular saw, hand saw, and a chisel. Nice. Now I can set up my table saw and cut these 40 to 45 groove. That'll sit on my guide. And then I check the height to the inside tooth right here, and I want that to be 1 inch. Wow. Basically right on the money. Wow. That was a beautiful experience. I was getting the walnut smell, and then I finished with a splash of yellow cedar. Oh, that's a good combination. Probably causes cancer, but damn, it smells good. Now that we've got our guide fit to our guide track, the next step is to transfer the joinery, or at least the width of the board, onto our dead man where it's going to hit the dead man. So I've clamped the dead man in place. Right now I have it tight on the shoulders up top, so I can always adjust that and cut that shoulder a little bit lower if I need space so that it doesn't bind in the track up here. But right now I just want to work on getting this joinery transferred perfectly. So I hold my piece down tight on my track where it's going to sit. My shoulder cuts right here are lining up just right on the edge where I want them, the inside of my dead man. Now you want to make sure that you have your dead man sitting plumb. All right, so there should be a gap of about, 1/4 inch, 5/16. I just measured off my post at the top to the inside of my dead man, and then I matched that at the bottom so I know it's sitting parallel with the leg. And then I'm going to transfer this mark right here, top and bottom. Now I know exactly where this piece is going to sit. I'll square those lines across, and then I'm going to lay out the tapered dovetail off of these reference lines. So here's my piece. So I'll mark in 3/8 of an inch, right, on each side. I'll measure down 1 inch. My combo square here. That's going to be the bottom of my dovetail. Then I'll draw the tapered marks from there. And then a center line, or you can measure from the edges. And then transfer the same amount of taper. Once you got your saw set up with the right angle and the depth, or at least what you think is the right angle and the depth, test it on a scrap piece of wood. And then double check, lay out, the right angle, 1 inch deep with the 3/8 offset, and then check to make sure your cut's right on. And then once you're good there, take it to your piece of wood. All right. You tell me if you can see what's wrong with this picture. Nothing wrong with the joint. It fits like a glove. Problem is, this V groove is supposed to be on this side. So I cut the mortise on the wrong side. Should have cut it in from this side so that it would be flipped that way. So, bit of a brain fart there, but that's why I didn't cut this to length, because I thought, hey, the first time cutting this joint, I might as well leave a little extra on here in case I have to nip it off and recut this joint. So that's what I'm gonna have to do. I'll just cut off this nice, perfectly cut joint and do another one. Haste makes waste. My loss, your gain. Make sure you orient the joint on the right side of the piece of wood. Check, check, double check. We are so close. Oh, this don't fit here. The nice thing about these is the closer they get to their placement, they get tighter and tighter and tighter. So it's just a really fun joint to get fitting just right, because it takes a bit of time, but once it's there, it's a beautiful thing. So close. Kind of a bit of cavity read the toe, I guess, and stuff too, so shoot a bit more off inside. You start to get these little polished areas where the high points, where there's the most friction, it'll kind of have a bit of a sheen in the light. And if there's no sheen, you can be pretty certain that that surface isn't got a lot of friction on it. So just find the shiniest spots and then file them down. Maybe take off the corner here. Just don't take it off at the part that's showing. And file back the corners, because sometimes there's junk in the corner of the mortise that's kind of clogging things up. Alright, I'm going to be here for a little while longer.
When drilling the dog holes on your dead man, set the depth on your drill press so that the tip of your drill bit just breaks through the back side, and then flip the dead man over and finish the holes from the back. Be extra careful not to drill holes through your dovetail joint.
Alright, so the detail on the edge of my piece here is kind of unique, which is always what I'm shooting for. It's not a full radius, it's kind of a slight radius, and so I have a big radius bit. I think it's about a 1 inch round over, but I don't put it full depth. I put it, 3/4 depth, and that way it kind of leaves this nice abrupt edge, gives it an Asian, Japanese kind of style. And then in the corners, I take my knife and I just run my knife in there, because obviously the router bit kind of rounds the corner like this. But I want to have it nice and defined, kind of a cloud lift style. So I'll just take my knife and kind of line it up with my straight piece right here, and then just roll it in on a bit of an angle to what I feel is the inside of the center of that arch. And just roll my knife back and forth a couple times. Get it in there about a 1/16 of an inch maybe. And then just slowly carve that into a corner. That's the big plug. That's how it's done. Wow. That is just poetry. Wow. Up until about 3/4 of the way through this project, I was just kind of so caught up in wanting the workbench that I was just enjoying the process, but just trying to get it done as fast as I can. Now I'm putting on these finishing touches and really seeing the workbench come to life, and it's kind of I almost don't want it to end. This has just been such a experience. This was a first for me. I've never done a joint or quite like that, and just to have it work just as good as you imagined it, or even better, it's just wow, what a feeling. This has definitely been a bucket list project and worth every moment and every penny, in my opinion. And actually far more. I never even thought I never even imagined it would turn out this well. And it's just, yeah, so rewarding.